In this series, we're going over every hard advanced math question on the SAT. This is part 1, going over every problem related to nonlinear functions. Specifically, this video will be going through questions 1 through 22. There are 88 questions in total, so this will be broken up into 4 parts. This has been a much awaited one, so I'm going to hopefully get this one out before the October SAT. As I said, all of these questions are the hard questions, so they're ones with 3 out of 3 on the difficulty rating, and they're all going to be in the domain advanced math with the skill nonlinear functions. For each question, there is a question ID up here in the top left. You can look in the video description. All of those question IDs will be listed along with a timestamp of the exact minute and second where I start going over that problem and a short topic description for that question. So you can use that to search for specific topics, or if there's a specific problem that you did and you want to find the solution to it, look for it there. Again, this will be broken up into 4 parts, the 4 nonlinear function parts. So if you don't find it in the video description for this video, just check the other ones, and you should be able to find every problem that's on the SAT online question bank. Diving right in, this question says, the product of 2 integers is 462. So product means we're multiplying them. The first integer is 5 greater than twice the second integer. What is the smaller of the 2 integers? All right, so first, if we just want to write it as 2 different integers, we could say they're x and y. So x times y is the product of those 2. Gives us 462. Now for the other equation, the first integer is 5 greater. So x is 5 greater. So think of x is, first integer is 5 greater, so 5 more than twice the second integer. So that'd be 5 more than 2y. What is the smaller of the 2 integers? So the reason this is a nonlinear function and not just a normal systems of equations is because we've got this product here, so x times y. I'm going to use substitution here. I'm just going to substitute it in, and actually some people would just have written it directly like this. They wouldn't even have written in x. If you do it like that in your head, that's fine. But either way, you end up with the same thing where you have parentheses 5 plus 2y and parentheses times y is equal to 462. Now from here, we can distribute this y to both elements that are inside of the parentheses, both terms there. That gives us 5y plus 2y squared, y times y is y squared, is equal to 462. And now if you want to make it so you have a quadratic on one side and 0 on the other side, which is how you can easily solve this, you just, again, I'll put the 2y squared at the front. So it's the commutative property of addition, doesn't really matter. Right? It doesn't change that, we change the order. But I'm going to subtract 462 from both sides. That will leave us with 0 over on the right because these cancel out. And we get minus 462 here. All right, so now you've got a quadratic on one side. Now we could try to factor this, and if you didn't have a calculator, that'd be a fine way to do it, but we do get a calculator. So I definitely would recommend on these nonlinear functions ones, don't waste time solving it in a more algebraic manner. It's fine to do that if you feel comfortable with it and you can do it quickly. You can also use the quadratic formula, right? You'd say A is 2, B is 5, C is negative 462. And then you just write x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, like that. And just plug in your a, your b, and your c. I would probably do that on your calculator as well if you've got a handheld one. But for this one, we really could just type this actual equation in and find the zero. So I guess you could put y in place of the 0 and just see when is y equal to 0. Now, I guess I say y, but be careful, like these I wrote them as y's. If you want to write those as x's when you type it in, do it like that and then see when y is 0. Or you could just write it this way, and then it's going to be a sideways parabola, right? It won't be a normal smile or frown. Then you have to see when the x is 0. So whatever you're substituting in here. But I'm just going to write those as x's. And you can use test mode. Desmos has a test mode app. So you just go here, do graphing calculator, and choose the one that is used by College Board. That will be the one that you'll have on AP math exams or on the SAT math. All right, so our equation, we had 2, again, you could write it as y squared or x squared. I'm going to write x squared. 2x squared plus 5x minus 462. And then we have to see when is that equal to 0. We've got 14 comma 0 and negative 16.5. I think they did say something about their positive integers, but let's check. All right, so there are 2 options would be 14 and negative 16.5. Again, if you did type that in as y, I'm just going to show you what it looked like. Like I said, it would be sideways. That. You have to do equals x then, but right, you get 14, negative 16.5. So this is the same thing, just you're seeing where it crosses the opposite axis. But either way will work. So our 2 answers were 14 and negative 16.5. And it says they're two positive integers, which means that we can eliminate this negative option. So that means that y is equal to 14. And ultimately what we're looking for is what is the smaller of the two integers? Well, they said the first and the second, so we don't necessarily know. I mean, the first doesn't mean the smaller of the two. In this case, actually, the first will be the bigger one. But we can see what we're doing to it. We're going to be doubling it and adding 5 to get x. So x will be bigger. But just to verify that, you go x equals 5 plus 2 times y, and our y we said was 14. So 2 times 14 is 28. 28 plus 5 will give us that x is equal to 33. So we know 33 is bigger than 14. Again, what is the smaller of the two integers? That will be 14. So let's say you do that. You didn't really need to do any factoring or algebra with that. The main algebra you're doing is the distributive property here, and then making sure you know how to interpret it. Now, if you do this quadratic formula, it would give you those same two options, 14 and negative 16.5. Again, reject the negative one just based on this fact. They said there are two positive integers. The function g is defined by g of x equals the absolute value of x over a minus 14, where a is less than 0. So a is a negative number. What is the product of g of 15a and g of 7a? So let's just first write this out. G of 15a and g of 7a, and we want the product of those two. So we're trying to find g of 15a times g of 7a. Plug in this 15a, the 7a for x in this function here. Then we will get, and Resham KC caught an error on this one, so let me just fix it up quick. So you have to plug each of these values, 15a and 7a, into this function g of x. What I did the first time, I forgot to do the minus 14, which throws off your answer. So first, let's plug in this 15a. So we have absolute value of 15a over a minus 14. Let me put that in parentheses. And let's put the 15a right there. And actually, before I write the 15, this, I guess if you're writing it with a pencil, is not something you can copy, but I'm just going to copy this, paste it here. So the same thing. Those are both the g of x function. One of them I'll plug in 15a in place of the x, and the other one I'll plug in 7a in place of the x. Now for both of these, because it says a is less than 0, we know that it's a negative number. So 15 times a is a negative number, 7 times a is a negative number, a alone is a negative number. But if you do the absolute value of that negative 15a, it becomes positive. But then we still have a negative a down the bottom. So I think it would be like a positive divided by a negative for both of these, 7a, or the absolute value of 7a over a, and the absolute value of 15a over a. So a positive divided by a negative is negative, which means that we can cancel out the a's, but just this will end up being negative 15 minus 14 over here. And then this one will be negative 7 minus 14. Right, because again, a divided by a cancels out, but then just keep track of those signs like that. All right, so negative 15 minus 14 gives us negative 29. And then negative 7 minus 14 gives you negative 21. Right, both cases they're making it more negative. Now we just multiply these two numbers together. A negative times a negative will give you a positive. So those cancel out. And then 20, let's see, if we take 29 times 21, gives us 609. So 609 will be our answer for this problem. All right, so just make sure that you plug it in, use the entire equation here. I think when I did this the first time, I was just rushing, forgot to do the minus 14 from each of those, which then made it so that the absolute values didn't really end up mattering because they canceled out in that case. But just, always keep track of, will the numerator be positive? Will the numerator be negative? And, then you can figure out your rules. If you have a positive divided by a negative, that's going to be negative. If you have a negative divided by positive, same thing, it would be negative. If it's a negative divided by a negative, that will be positive. And then same thing when you're multiplying, right? Positive times positive makes positive. Positive times negative makes negative. Negative times positive, same thing. And then negative times negative is positive. All right, so let's move on to the next question. All right, here we have a table. It gives us x values and g of x values. So these are inputs or outputs when you put it into this g function. The table shows 3 values of x and their corresponding values of g of x, where g of x is equal to f of x over x plus 3, and f is a linear function. All right, so f is linear. I mean, we could treat that as f of x equals mx plus b. We don't know what m and b are yet, but you can probably figure that out. And it says, what is the y-intercept of the graph of y equals f of x. So that will just be the b value. All right, so if you write it out like f of x equals mx plus b, we just have to figure out what that b is. Well, it looks like because we have this table of points, we could plug it in. So I'm just going to rewrite this with f of x written out with the mx plus b. Again, we still don't know what the m or the b are yet. But we could say, right, g of x equals, so it's supposed to be f of x divided by x plus 3. So we leave the x plus 3 in the denominator as is, but we'll write this as mx plus b. mx plus b. And just to help keep track, I'm going to make all of the x's purple. So whatever you input here goes in for this x in the numerator and this x down in the denominator. All right, so now we can just choose some points. So let's do when x is negative 27, the output is 3. So our output will be 3 when we have m times, see our x is negative 27, plus b, again, we still don't know what b is, all over negative 27 plus 3. So this is going to give two different variables, m and b. So it looks like we'll probably have to write another equation using one of the other points, and then we can solve it. Ultimately, you're making a system of equations here. Just it's a little more complicated how you get to that in the first place. All right, so negative 27 plus 3 is going to make it less negative, so it would be negative 24. And then we can just write this as negative 27m plus b. All right, and now to get the m and b part alone, I guess we can multiply everything by negative 24. So times negative 24 on this side, and I guess just for continuity, maybe I'll copy it down here, because otherwise I have to multiply, right, every part of the equal sign by it. So I'll say this. So I'll say 3 is equal to this, and then again, we're multiplying by the denominator, negative 24 times negative 24 on both sides. So the negatives will cancel, the 24s will cancel, and then negative 24 times 3 will give us negative 72. So negative 72 is equal to negative 27m plus b. Okay, so there's one equation. And now we have to do another point. So let's do this negative 9 and 0. Hopefully the 0 will make it nice. So we'll have 0 as our output. So 0 goes in for g of x. Is equal to, again, it's going to be m times x. So m times the x value is negative 9 plus b over x plus 3. Well, x again is negative 9. So negative 9 plus 3 down in the denominator. And I'll do the same thing. I'll do the denominator first. Negative 9 plus 3 makes it less negative, so it'll be negative 6. And then we have negative 9m plus b. And this is all equal to 0. All right, so I guess same thing. We can multiply both sides by negative 6. So over here, negatives cancel, 6's cancel. Negative 6 times 0 is just 0. So we'd say 0 is equal to negative 9m plus b. All right, so now we have two equations. We have this one and we have this one. So we need to figure out what b is. I guess two ways we could do that. Well, we could do substitution as well, but we could do it algebraically, which I would think looks like elimination would be the easiest way. Or we could type both of these equations into Desmos. You just have to make m into x and b into y, or vice versa. Just whatever you put them as, make sure that whatever m is in this equation, m is also that same variable in the second equation. Same thing with b, and then keep track of which one is which, so you'll know which one is b. I'm going to just show quickly how to do this using elimination, because we could see we have negative 27, negative 9. 9 times 3 is 27, so this is actually pretty easy to do elimination. What I'll do is just multiply every term by negative 3. So negative 3 on the left, negative 3 on the right. That gives me, well, negative 3 times 0 is still 0. So we have 0 is equal to positive 27m minus 3b, like that. Now if we combine the left sides over here, combine the right sides over here, we get negative 72. I'll do this in purple so it's clear. I'm combining the two, the red and the blue. Negative 72 plus 0 is negative 72. 27m plus, or negative 27m plus positive 27m cancels out. That was the reason we did this, get rid of our m's. So we get 0. And then b minus 3b, or b plus negative 3b, is negative 2b. I think you just get rid of the 0. We have negative 72 is equal to negative 2b. To get b alone, we just divide both sides by negative 2. That will give us that b is equal to positive 36. Right? The negatives cancel. Half of 72 is 36. And so b is 36, and the y-intercept is when x is 0, how high up is it? That's the b value. So 0, 36, that would be a. All right, so that's how you do that with elimination. I guess quickly I'll show you how you could just type this into Desmos. So we had negative 72 equals negative 27m plus b. and 0 equals negative 9m plus b. I guess actually when I think about it, I often will tell people don't, when you type into Desmos, type it in an ugly form, just in a way that you didn't have to do that much math. So you could even just type them in as you had them at the start there. So 3 is equal to m times negative 27 plus b over negative 27 plus 3. Now, I did the algebra correctly here, so I know that this is equal to negative 72 equals negative 27m plus b. But, if you want to mitigate any risk of it, you just put it in like that. And then we could also put in 0 equals m times negative 9 plus b over negative 9 plus 3. Now, again, we have to choose which one's going to be x, which one's going to be y. I will write on my paper here, and I could write it right here. I'm going to say that m is going to become x, and b is going to become y. And we want to solve for b, so we're going to want to solve for y. 3 is equal to, and we'll do x in place of the m, x times negative 27 plus y, which is in place of the b, all over negative 27 plus 3. And you can see I didn't even simplify that. I didn't even write negative 24, just to remove any opportunity for me to have messed up any math that's in the steps. All right, so I just wrote that in where I plugged in 3 was one of the points, the outputs for g of x, and negative 27 was the input that corresponded to that 3. All right, so that's one equation. And then we do the same thing with the point negative 9 comma 0. So when your output is 0 for g of x, so when your input was negative 9, your output's 0. So there's our output 0 is equal to, and I'm going to do a fraction again. Let's say it's m times negative 9, so I'll write x times negative 9 plus b, which again, b we're putting in as y, and that's all over the negative 9 plus 3. Again, I didn't even write negative 6 because it already does that for you. All right, so now we've got these two graphed, and then you see where they cross, 4 comma 36. Again, we were solving for the b value, so the b value would be 36. Now we also know that our slope is 4 for that function f of x. And I'll just write this down. So it's 4 comma 36 is that point where those two cross. So that means, again, m comma b is 4 comma 36. So if we wrote out the function f of x, then f of x would be equal to 4x plus 36. This is our m value, this is our b value. We're ultimately looking for what is the y-intercept of this. So the y-intercept of a linear function, when it's written in slope-intercept form like this, would just be what you're adding at the end. So think about when x is 0, plug in 4 times 0, you get 36. So that's going to be 0 over 36 up. Like that. So again, it's still a. And I think, that was pretty much the same amount of time as doing it with elimination. If you're a little bit unsure of your ability to, add and subtract integers, if you have some negative values or think that you'd mess up this algebra, then you just go straight to Desmos. If you could type quickly, it might be a little bit faster. But if you're comfortable doing this, you could do the elimination. You really don't need to use Desmos. You can see that elimination was very quick, as long as you could recognize that negative 9, negative 27 are, they share that common factor of negative 9. So it's easy to manipulate them so you can get rid of the m's. But either way is acceptable. H of x is equal to 2 times the quantity x minus 4 squared, then minus 32. So this is a quadratic. If you have a quadratic in this form, it's called vertex form. It would usually look f of x, or I guess I could write h of x. We could say y is equal to a times x minus h squared plus k. And what that means, a is just what you're multiplying it by. It's the same a value that you'd have if you wrote it in standard form. So if it's above 1, then it makes it thinner and taller. If it's something between 0 and 1, then it makes it wider. And same thing, but inverted. If it's negative, it's just going to be a frowny face, but it's still, right? If it's between 0 and negative 1, then it's going to be wider. And if it's, I guess, a greater absolute value than negative 1, but less than negative 1, then it's going to be thinner. The h comma k represents the vertex. So if it's a positive parabola, right, one that's going up, that'd be the minimum point. If it's a negative parabola, then it's going to be the maximum point. Right? But that's the vertex. Okay, so just looking at it, we have a positive parabola because that's 2, we have the 2. And our vertex for this is going to be positive 4, comma negative 32. Just think it's x minus h. So what are you subtracting from x? Or you think, when is this thing equal to 0? When x is positive 4, because 4 minus 4 is 0. So we'd get our vertex is 4, comma negative 32. Our a value is 2. And the quadratic function h is defined as shown. In the xy plane, the graph of y equals h of x intersects the x-axis at the points 0, 0, and t, 0, where t is a constant. what is the value of t? Okay, so they're just looking for the zeros here. I mean, we could do this algebraically. It wouldn't be that difficult. You just have to multiply this all out and then you could factor it. I can show how to do that, but I'll show you how you really should do this one. You get Desmos for the whole test, so you might as well just type that equation in, see where the zeros are. So we have, is it h of x, and you can write that as y equals, but it doesn't really matter. H of x equals 2 times the quantity x plus, or x minus 4, x minus 4 squared minus 32. Just go over to Desmos, y equals 2 times the quantity x minus 4 and quantity squared minus 32, like that. And let's go to our zeros. We do have one at 0, 0, it passes through the origin, and we have one at 8, 0. So all that stuff I talked about with the vertex form and finding the vertex, you didn't actually need that for this one. All we're looking for is that other 0, which is at 8, 0. But just to verify, like we did do it correctly, 4, negative 32, right? That is in fact the vertex. It's in this case the minimum because it's a positive quadratic. All right, so 8 is what they're looking for, which means that t is equal to 8. I guess, I'll quickly show how you could do this algebraically. I think it's an important skill. So you just first would multiply x minus 4 times x minus 4. Foil that out if you don't know how to do it in your head. But x squared minus 8x plus 16. You do x times x times negative 4 times x, and then negative 4 times negative 4 gives you the positive 16. So we get negative 8x. The whole thing is being multiplied by 2. You could also multiply it by 2 first, then do the foiling if that helps you, but I don't know, to me, I think that it's easier a little bit this way. And we have this. We want to find the zeros, so when y is equal to 0. And now I'll distribute this 2 to everything. It gives me 2x squared minus 16x plus 32 minus 32, like that. It's equal to 0. And now positive 32 and negative 32 cancel out, so we're just left with 0 is equal to 2x squared minus 16x. And now we can just factor out a 2x from both of these. 2x times, this divided by 2x is just x. Negative 16x divided by 2x would be negative 8. So we get 0 equals 2x times the quantity x minus 8, like that. That's pretty simple factoring because you're just pulling out a GCF. You're not actually doing like the opposite of foiling here. And think, when is this equal to 0? When x is 0. And when is x minus 8 equal to 0? When x equals positive 8. Right, so 8 and 0, they gave us the 0, 0, 1. So we just have to figure out what's the other 0 value there. What's the value of t? That would be, in fact, 8. Okay, so let's say you do that. If anyone's confused by what I was doing with this, just think if you multiply two numbers, right? 2x is a number, x minus 8 is a number. Those are both factors of this. When you multiply two numbers and your product is 0, one of the numbers had to be 0. Right? The only thing you can multiply something by to get 0 is 0. So one of these has to be 0. So this is 0 when x is 0. This is 0 when x minus 8 is 0, which is when x equals 8. Right, we have f of x equals x squared minus 48x plus 2,304. What is the minimum value of the given function? All right, so this one is written in just standard form, ax squared plus bx plus c. The a value is 1. Now, we could factor this. I assume it will probably be, they don't say anything about rounding, so there's a good chance it actually will be like a whole number answer here. To find the minimum is the vertex. In this case, right, it would be the vertex because it's a positive parabola. So right, the vertex would be the minimum for one that's a smiley face. Now, you could complete the square to get this into that form because vertex form looks like this. It's a times x minus h squared plus k. Right, that's equal to, I guess in this case, f of x. Completing the square, some people will use the axis of symmetry. That will work. I would just say you get Desmos, so you might as well type this in and get it as is. I guess if you've taken calculus, you could also do this using calculus because the minimum is where the derivative will be 0. So I will show how to do that after. Some students will have taken calc when you do the SAT. Most will not. You do not need to know calculus by any means. It goes up to algebra and then some basic things in geometry, but a lot of the math that's on the SAT stuff that you'll have learned way before calculus. There is some trig on it, but it's not trig that you learn in Algebra 2 trig. It's usually the trig you learn in algebra and geometry. It's essentially just SOHCAHTOA. I think there's something where the unit circle could help. But anyway, we're getting ahead of ourselves. You don't need to know pre-calc or calc to get every question right on the SAT. But anyway, let's type this in. F of x equals x squared minus 48x plus 2304. So we'll go to Desmos, type that in, And I don't even think you need to write the y equals, but I'll probably write it. So x squared minus 48x plus 2304, that's equal to y, you'd say. I have to zoom out to see it. Oh, it's all the way up here. All right, so this one has no zeros, but that doesn't matter for finding the vertex. The vertex is just either the minimum or maximum point. So it's 24, 1728. And I don't remember if they said to find the x or the y or both, but let's just write both down. What is the minimum value of the given function? So by value, they mean the output, right? So the function is what we're plugging in for y. So the given function would be the y value. Again, our coordinate of the vertex was 24, 1728, which is actually 12 cubed. I think that's just a coincidence here. I was looking if it was something with like divide by 2 and then cube it or something like that. So our minimum value is 1728. Right? Now that could confuse some people because I think some of my students say, what do they mean by value? Do they mean the value input or the value output? But of the function, right? The function is what you're doing to get the output. So the minimum output, I would say, of the function. Still, I don't love the wording there, but that's what they mean. Now, just to show quickly, if anyone is curious who understands at least the power rule of calculus, say, when is the derivative of this equal to 0? Because if you reach a minimum or a maximum point, that means it was increasing. It's going up, 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 and then it's going down if it's a maximum, or in this case, it's a minimum. So it's going down, 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 then it's flat. For instantaneously, it's flat, so just for like not even a second, and then it's going up. All right, so at this minimum point, or again, if it was a negative parabola, which this one's not, at that maximum point, the rate of change would be 0. Now, calculus has some tricks to quickly find the rate of change at any given point, and there's something called the power rule. So if we have x squared minus 48x plus 2304, to find the derivative of that using the power rule, what you do is you just take the exponent and you multiply like that term by it, and then decrease the exponent by 1. So in this case, x squared would become 2x to the first, which is just 2x. And then here we have, you could write negative 48x as negative 48x to the first power. If it's just an x, that's x to the first power. So you'd multiply the whole thing by 1, which gives you negative 48. And then you decrease that x to the 1 to x to the 0, which anything to the 0 power is just 1. Negative 48 times 1 is negative 48. Over here we have, right, this is essentially 2304 times x to the 0 already, right? There's no x's there, it's just times 1. So if you multiply the whole thing by 0, it just gets rid of that term. The other thing that you would learn in calculus is the derivative of a constant is 0, of any constant. Even the derivative of pi, which some people get confused. You're like, oh, that's a variable. It's pi to the first power. No, pi is a constant, right? Just because we write it with a letter, a Greek letter, but just because we write it with a letter does not mean that it's actually changing values. So, right, the rate of change of pi is always pi. So the rate of change is always 0. Same thing, 2304, it's not moving, it's always staying at 2304. That's the set value, it's a constant value. Constant means it's not changing. All right, so this is the derivative of that. And again, we just set that derivative equal to 0 because at a minimum or maximum, the rate of change is 0. So 0 equals 2x minus 48. Then you just have to solve for what x is by adding 48 to both sides. We get 48 equals 2x, so that means that x is equal to half of 48, so x is equal to 24. You can also divide both sides by 2, get like that. But 24 times 2 is 48. All right, so x is 24. Again, that's not our answer. But what you could then do is plug 24 in. We already know from like looking at the graph of it, when you plug 24 into this, the output is 1728. Right? But if you were using your calculator, you just write 24 squared minus 48 times 12 plus 2304. 24 squared is 576 minus 48 times 12. That's going to be 12 squared times 4. So 144 times 4 would be 576. So those cancel out. Wait, what? Oh, I see what I did wrong. I was going to say like that would just give you 2304, but this is supposed to be 24. I put in 12. So be careful. That's why maybe doing the calculator way. It's already faster and easier, but I guess you could always mistype something. So this should be double that. Should be, what is that? 1152. 1152 plus 2304. And when you subtract this from this, that's just going to be 576. Again, if you have double 576 subtracted from 576, it gives you negative 576 plus 2304. And then, again, you can just use this as a calculator for this. I don't know why I'm doing this, but whatever. So 2304 minus 576, go like that, go like that. Okay, so 14 minus 6 is 8, 9 minus 7 is 2, 12 minus 5 is 7, so 1728. Right, the same answer we got here. And if you just type this into your calculator, you'd get that. All right, so that's how you could do it with calculus. Really not necessary. When you have Desmos, just type this in. Make sure that you know when they say what's the minimum value they're looking for. What is the minimum output, minimum value of the function? All right, the function f is defined by f of x equals the quantity -8 times the quantity 2 raised to the x power plus 22. So this is an exponential function here. You write it out as like f of x equals a times b to the x, I guess plus c. A lot of times they don't have a plus c part, but the growth factor is 2. The initial value is -8. Well, actually, it's not the initial value because you have this plus c over on the side. All right, so anyway, they're asking, what is the y-intercept of the graph of y equals f of x in the xy plane? So the y-intercept is just when x is equal to 0. So this is not as complicated as it might seem. If you're thinking, oh, I haven't done exponential functions in a while, if they ask something like this, that's really not something to stress about. You could just type this into Desmos and see where it crosses, but this is one that's honestly, I think, faster to do without doing that, because you just plug in 0 for x, right? Just know that the y-intercept is always when x is 0. It's where it crosses the y-axis. The y-axis means you haven't moved anywhere over from the origin in the x direction. You haven't moved to the left, haven't moved to the right, it's just on that y-axis. Right, so -8 times the quantity 2 to the 0 plus 22. 2 to the 0 is 1, so anything to the 0 power is 1. So this is just going to be -8 plus 22. So essentially, this question just asked you what's -8 plus 22, which is something that I think some 6th graders and a lot of 7th graders would learn how to do. Or if you want to write it in a nicer way, in a way that some 2nd graders or 3rd graders might know how to do, just do 22 minus 8. And that would give us that the answer is 14. And so we have 14 for our output. I guess any y-intercept will have a 0 for the x value. So we write it as 0, 14, which is option A. Right? I'm not even going to show how to type that in Desmos, but you just type this exactly like that, or y equals, just see where does it cross the y-axis, and it would be at this point 0, 14. Right? And then you're good. An auditorium has seats for 1,800 people. Tickets to attend a show at the auditorium cost $4. For each $1 increase to the ticket price, 100 fewer people or 100 fewer tickets will be sold. That makes sense. If they're more expensive, fewer people will buy them. This situation can be modeled by the equation y equals -100x squared plus 1400x plus 7200 or 7200, where x represents the increase in ticket prices in dollars and y represents the revenue in dollars from the ticket sales. If this equation is graphed in the xy plane, at what value of x is the maximum of the graph? So same thing here. We could complete the square. We could do that calculus method that I talked about in the previous one, where we just set the derivative of this function equal to 0. That would actually be easier for this one because it's just saying find the value of x. So I'll probably show how to do it for this one. Actually, I think I hyped it up as if the calculus solution for the last one would be faster than Desmos. In the last case, it was not. This one, I actually think it would be. I'll do the Desmos solution first because I think that's what most people will use on this. And again, I don't want to stress people out that you need to know calculus. Calculus just basically can potentially give you a shortcut for some of these SAT questions, but in general, right, we really don't need calculus at all. And when I say shortcut, it's probably a matter of like 5 seconds, and that's only if you're working pretty quickly. Because, just typing this in, it was -100x squared plus 1400x. And I think I have not the greatest habit of, I don't write y equals at the start when I'm doing it, but technically if you're in a rush, it graphs it even without writing that in most cases. So we have to zoom this way down. It started it way up. So plus 1400x plus 7200. Now we just have to figure out what is a maximum. So they were actually helping us out there. Let's see, what's that maximum? It's 7, 12,100. And I think we just needed the x value. So 7 would be the answer there. And just to show that it doesn't change anything, if you write this is equal to y, it's the same thing. It's 7, 12,100. So let's go back to the answer choices here. And they're asking what is the value of x? So it was 7, 12,100. So our x value was 7. Right? So that's very quick, especially if you could type quickly. I will show that I think in this case the calculus way might be faster. So we just do the derivative of this function I underlined in pink and set it equal to 0. So in the derivative, we just multiply the exponent times the coefficient and then decrease the exponent by 1. So this -100 times x squared, the derivative would be -200x, or x to the first, plus 1400x becomes just 1400. Right? X to the first, you multiply everything by 1, and then the x to the 1 goes to x to the 0. And then again, a constant, the derivative of a constant is always 0. Because you think of it as x to the 0, you're multiplying everything by 0. All right, so this is equal to 0. Now, I know that already took about as long as it would take to type it in because I had to explain it. But if you've done these enough, like you could do that derivative really quickly. So we have 0 equals this, and then you're just figuring out when is that true. So subtract 1400 from both sides. You get negative 1400 equals negative 200x. And just think what times negative 200 gives you negative 1400. Or you can also think of it as dividing both sides by negative 200 to get the x alone, so just 1x. That's going to be x is equal to 7. Right, so I actually think if you did this quickly, because if you've done enough derivatives of power rule, or using the power rule, you could quickly get to this derivative. Notice set it equal to 0. And then this algebra is so quick that you could really get to x equals 7 faster than you could even type it in on Desmos. That would save you such a small amount of time that if you don't know how to do this, I really recommend just type this into Desmos. I'm not going to show how to complete the square, because completing the square actually would take a lot longer. I mean, if you divide everything, oh, you know what, maybe I can show it. Let's see. I would start by dividing everything by negative 100 here, because the vertex is not affected by that a value. So we take negative 100 out of each of these. Negative 100 divided by negative 100 is 1. Negative 14, or positive 1400 divided by negative 100 is negative 14. And that should be 1400x, so it becomes negative 14x. And positive 7200 divided by negative 100, positive by negative is still negative, and that would be minus 72. All right, so now we have our a value is negative 100. That's the thing out front. So we get y over negative 100 like that. It's equal to x squared minus 14x minus 72. So you need to complete the square so that you can get it into vertex form, because we need to have something squared. I was about to factor it, which would help you find the zeros, but it would not help you for finding the vertex. You could also use the axis of symmetry, which would be, you set x equal to negative b over 2a. Do it from here. That would be, what is that? Negative 14 over 2 times 1. That would be negative times negative positive. So it's positive 14 over 2, which equals 7, which is our answer. So I guess, yeah, if you remember to do the axis of symmetry, right, the axis of symmetry will be the x value of that minimum or maximum. If you needed to find the output, right, like the previous problem when you're finding the maximum or minimum value, then you just plug in that value of x as the x, and then you could figure out what the output is, which would give you whatever it was before. I think it was 12,100, something like that. You do need to remember that negative 100 to bring it back. But yeah, if we do this, you would have to make it into, you take half of the b value, so that'd be negative 7. So you want to make it x minus 7 squared, which should give you positive 49, negative 7 times negative 7. So you'd have to think, all right, what do you have to add to positive 49 to get negative 72? So you could add 49 and subtract 49, right, because it's like adding 0. So this whole thing is what becomes the x minus 7 squared, the x squared minus 14x plus 49. And then you still have at the outside negative 72 minus 49, which would just give you ultimately negative, 121. So you get x minus 7 squared minus 121. And then you have to multiply this whole thing by negative 100 on both sides. So this by negative 100 like that. You'd end up with negative y equals negative 100 times the quantity x minus 7 squared. And then negative 100 times negative 121 gives you a positive 12,100. All right, so here you can see our a value is still negative 100. Our h comma k would be 7 comma 12,100. Let me just write it as 12,100 with no comma there, which is the same thing we got. So actually this one wouldn't be that hard if you didn't have a calculator, but you have the calculator, so why bother doing this? And I think a lot of students don't like completing the square. I think it's kind of fun. But anyway, you could do this the calculus way, right, finding the derivative. You could do it with the axis of symmetry. Just make sure you remember that x equals negative b over 2a. If you don't remember that 100%, probably don't use it. But you can just look at it right before you go into the test, I guess. If you know how to complete the square, that works. But I'd recommend either if you've taken calculus, maybe do the calculus way. Otherwise, just type this equation in, see what that vertex is, and make sure the most important part, what are they looking for? What value of x? So do not give the y value. You wouldn't have to worry about it here because they have options and there's no 12,100, but make sure you always know what they're looking for. All right, and these numbers here, I just wrote what number each question is. So that was question number 7. I'm gonna just go to question 22 for this video, and we'll get the other 66 of these in subsequent videos. All right, so we have f of x equals 9,000 times the quantity 0.66 raised to the x power. So this is an exponential function. Specifically, it's exponential decay. We know that because the growth factor, in this case is the decay factor, is less than 1. So it's something it's shrinking at each time. Our initial value, the principal value, is 9,000. So the given function f models the number of advertisements a company sent to its client each year, where x represents the number of years since 1997. So x is the years since 1997, which means that this 9,000, the initial value, is the number of views or the number of advertisements in 1997, and then each year after that you're multiplying it by 0.66. And it says and 0 is less than or equal to x is less than or equal to 5. So it only goes until 5 years after 1997. So it means it goes until 2002. If y equals f of x is graphed in the xy plane, which of the following is the best interpretation of the y-intercept of the graph in this context? So the y-intercept is when x equals 0. We already talked about that. X is the number of years since 1997, so when x is 0, that is 1997, right? 0 time has passed since 1997, and then it's just what are the number of advertisements, so what's the output of this function when x is 0? You could type that in your calculator if you don't feel certain, but anything to the 0 power is 1, so this whole decay factor turns into 1. 9,000 times 1 is 9,000. So when x is 0, that's in 1997, the number of advertisements is 9,000. Just looking for something like that. The minimum estimated number of advertisements that the company sent to its clients during the 5 years was 1708. I mean, I don't know if that's true. That would be when x is 5. So you multiply 9,000 times 0.66 to the 5th power. But that has nothing to do with what the y-intercept is. The y-intercept is when x is 0. So for this, actually, it's the maximum. Because it's not going to get... You can't go to negative time because it sets the minimum for this domain as 0. But yeah, it's just going to keep getting smaller as time passes. It says the minimum estimated number of advertisements the company sent to its clients during the 5 years was 9,000. So 9,000 is the right number, but they're not looking for the minimum, right? They're looking for the starting value. So look for something that says the starting value, or you can even say the maximum. Again, like we said. So the estimated number of advertisements the company sent to its clients in 1997. That's really what they're looking for. So when x is 0, that means it's in the year 1997, but the number's wrong, right? So it's not 1708, it should be 9,000. So we know it's going to be D, but the estimated number of advertisements the company sent to its clients in 1997, so when x is 0, that is 1997, was 9,000. All right, so this one, really, there wasn't much math involved. It's more just making sure that you understand how an exponential function works, understand the context of this word problem that they gave you. The first term of a sequence is 9. Right, so we start with 9. It doesn't say if it's arithmetic or geometric yet. Each term after the first is 4 times the preceding term. Okay, so it's geometric because we're multiplying it by 4 each time. So say it starts at 9, then the next one you multiply that by 4 is going to be 36. Multiply that by 4, that would be, 144. Okay, so keep going like that. If w represents the nth term of the sequence, which equation gives w in terms of n? All right, so if you wanted to write this as a recursive formula, you would do it differently. You do like w0 equals 9, or you could say w1 is 9, and then wn is equal to the previous term, which would be wn minus 1 times 4. And so you write like that, that would be the recursive way to write this. But they're looking for not the recursive formula, they're looking for the explicit formula. Don't get thrown off by the fact they're exponents. That doesn't mean it's exponential. We're not raising it to power each time we're multiplying it by something. That's just like how many times you have to multiply by 4. To go from the first term to the second term, you have to multiply by 4 to the first. To go from the first term to the third term, you have to multiply by 4 squared, right? Times 4 to get the second term, times 4 to get the third term, right? And so on, right? You have to do 4 cubed, and so da. Now, for this, right, we'd say our starting value was 9, right? So w equals 9, and we're multiplying it by 4 each time, so it's going to be 4 to a power. But we can't just do 4 to the n, because that would mean when n equals 1, then it's 9 times 4 is 36. And even though sometimes you'll talk about like the 0th term or starting at time 0 or something like that, for a list where it's a sequence, in general, you're referring to the first term as when n is 1. Right? So the first term is 9, which means that when n is 1, you don't want to multiply by 4, you want to multiply by 1. So we do 4 to the n minus 1 power. Because then when n is 1, you get 4 to the 1 minus 1, that's 4 to the 0 power. Anything to the 0 power is 1. So 9 times 1 is still 9. And then for the second term, when n is 2, you get 9 times 4 to the 2 minus 1, right? We don't want to multiply it by 4 squared to go from 9 to 36. We want to multiply just by 4. So 4 to the 2 minus 1, 2 minus 1 is 1. So that's 4 to the first. 9 times 4 to the first would give you 36. So if you write out some of the terms in the sequence, you can plug it into these and see. That can at least help you rule out the wrong answers and hopefully can help you get to the right answer. All right, so we knew it's not one of these ones because the thing being raised to the power is the common ratio for what you're multiplying by to go from one term to the next. And again, it's not C because you can't just raise 4 to the n power. It has to be the n minus 1 so that you start at 9. I mean, the other way sometimes people will do it, I don't think the SAT does this, but you could write it as like 9/4 times 4 to the n, so like that. And then n can be 1 because we'll just cancel out the 4 in the denominator. But I wouldn't worry about it that way. This is the more common way. The function f is defined by f of x equals a times the quantity 2.2 to the x plus 2.2 to the b end quantity, where a and b are integer constants and 0 is less than a is less than b. So a and b are both positive and b is bigger than a. The functions g and h are equivalent to the function f, where k and m are constants. Does it just mean in place of the a and the b? I don't know. Let's keep reading. Oh, they have them down here. Okay, that makes more sense. I was thinking, like, they don't specify, they just say that they're constant, just say where they are. All right, those functions are given below. It's probably going to say that. I should say the functions g and h below, but anyway, whatever. Which of the following equations displays the y-coordinates of the y-intercept of the graph of y equals f of x and the xy plane as a constant or coefficient? The main thing that's important is that those functions are equivalent to them. It's just written in a different way. Interesting. Okay. So I guess the important thing to gain here, so a being a constant is standard, right? That's even if you just wrote exponential form, usually you use an a. It would be like a times, it's going to be confusing because they have a b there, but generally they'll write it as a times b to the x, and then occasionally have a plus c at the end, right? Like that. Now, the b that I was just talking about is 2.2, right? 2.2 is your growth factor, and you're raising that to the exponent, okay? So this whole thing here, 2.2 to the b, we don't know what b is. They didn't tell us what b is. We just know it's bigger than a. It's just a number. So 2.2 to some power is going to be a constant itself. Now, we don't know what that constant is, but this is just some number. Let's call that n, okay? N for number. We don't know what the number is. It's also not used in any other way. All right, so we have it like that. A times 2.2 to the x plus n, all in parentheses. So you're multiplying both of those by a. Okay, so if we distribute the a to these, you'd get, I mean, this we're just going to leave out front. So a times 2.2 to the x. And that's this first distribution. We have to distribute it this way too. So it's going to be a to the n. And again, n is just equal to this 2.2 to the b. So plus a times 2.2 to the b, which this whole thing is a constant, right? You could write it as an or a, right? Whatever this is, 2.2 to the b. B is not a variable, but this is just, there's some value for this, and a also has some value. Okay, so yeah, I mean, that's the main thing here, is that this is going to be a constant. You leave the a up front, which both of these, well, this one doesn't seem to do. This one is just writing it like this. Okay, so n is just in place of the k, I guess. And, you know, like I said, this is a constant. So this we could change to m, because that's what they wrote it as here. Right, this is a constant. So you could do a times 2.2 to the x plus m, because it's plus a constant at the end. Or again, you could leave that whole thing in there, just know that, right, 2.2 to the b can be written as a constant k. So both of these are acceptable. Right? So it's just saying, which of the following equations displays the y-coordinate of the y-intercept, the graph y equals f of x, in the xy plane as a constant or coefficient? Oh, okay, so that's the tricky part here, is it says, so both of those are appropriate ways of writing it. I thought that was what the question was asking, like, are those acceptable ways to write it? They are acceptable ways to write it, which I guess they told us down here, right? Because they said g of x and f of x. So these are other ways of writing it. But what they're asking is are k and m, or, you know, are either k or m, or both of them, the y-intercept? And they're not. Because for an exponential function, the y-intercept is going to be when x is 0, right? Or for any function, when x is 0, that's your y-intercept. So you think of this as it's a times 2.2 to the 0. That's just a times 1. So you're still left with the a. And then it's either going to be, for this top function, it'd be a plus ak right? So that'd be your y-intercept for the first one. Or for the second one, it would be a times 1, so it's a plus m. Right, so either of these would be the y-intercept, but it's asking about which of the following equations displays the y-coordinate of the y-intercept of the graph as a constant or coefficient. Technically, you could say it is the coefficient a if m happened to be 0. There's not a way for that to be true, though. Right? There's no way that that's 0. So yeah, there's really just no way that that's true. So this is kind of a tricky question. It's going to be neither 1 nor 2, because again, for this first one, it's a plus ak. Right? That's not just a constant or coefficient. It's these two constants, a and k, combined in this way, where it's a plus ak. And same thing here, it's not just m, it's not just a, it's the sum of the two of them. All right, so that's what we're doing here. I guess me misinterpreting the question maybe helped some people explain how we went from this to this. But regardless, when you get to that ultimate question, it's just are either a or m or k representing the y-intercepts? They are not. Right? Anytime you get a y-intercept question, just plug in 0 for x, because we know that's true for the y-intercept, and that's a good way to check it. Function f is defined by f of x equals negative a to the x power plus b, where a and b are constants. Okay, so a and b are not variables. In the xy plane, the graph of y equals f of x minus 12 has a y-intercept at 0, negative 75 over 7. The product of a and b is 320 over 7. What is the value of a? All right, so let's figure this out first. So let's write this whole thing where you have the y-intercept like that. So we get y equals, what is it, f of x minus 12. You write this whole thing. So negative a to the x plus b is the f of x part, minus 12. And they say the y-intercept is this. So when x is 0, that's your output. So negative 75 over 7 is equal to negative a to the 0 power plus b minus 12. Okay, so anything to the 0 power, doesn't matter what a is 1. So you can write this as negative 1 plus b minus 12, which is going to be b minus 13. Right, so negative 75 over 7. Be careful. I think a lot of students, their inclination is when something's raised to the 0 power will make it 0. And especially when you're multiplying it by something, raising it to the 0 power means it doesn't really matter because you're just multiplying it by 1. 1 is the identity number for multiplication. It doesn't change it. But for addition, it's not. So it will affect it here, this negative 1 thing. And it does stay negative. Even you could think, oh, negative 1 to the 0 power is also 1. That's true. But this is not negative a all raised to the 0 power. It's just the a being raised to the 0 power, and then you have the negative out front. So this is still going to be negative, and then whatever a to 0 is, so negative 1. Right? If I write it like that, might help a little bit. But anyway, so we've got this, which means we can figure out what b is by just adding 13 to both sides. And that gives you b is equal to 13 minus 75 sevenths, which is we write 13 sevenths, right? So multiply it by 7 over 7. That's the equivalent value of 1, right? Anything divided by itself is 1. So 13 times 7 is 70 plus 21, 91. I should have known that because it's one of those ones where you think it's a prime number, but it's not. So 91 over 7 minus 75 over 7 would give us 16 sevenths. So that's b. And we want to find the value of a. So the product of a and b is, okay, so that's where this is going to come in. So the product of a and b, a times b is equal to 320 over 7. And now we know what b is. We just found that here. So we just plug in 16 sevenths for b. So a times 16 sevenths equals 320 sevenths. Now we can multiply both sides by the reciprocal of 16 sevenths, 7 over 16, like that, because this will cancel out. We get 7 divided by 7 is 1, 16 divided by 16 is 1. So it just leaves us with a on the left side. And then it's nice as over here, the 7's cancel. So we get 320 divided by 16, which we can simplify because we know 32 is 16 times 2. So we take a 16 out of the top and the bottom. And this could be 2 times 10, so 20. So a is equal to 20. And what is the value of a is what we're looking for, so we just say 20. And I guess you could check this with Desmos. So if you want to type it in, right, just do that initial function. You'd say negative 20x plus, what is our b value we found? 16 sevenths. And that would be f of x. And we're subtracting 12 from that to get this y value here. And they said the y-intercept is supposed to be 0, negative 75 sevenths. I don't know if it will give it as a fraction, but let's see. We could do negative 20x plus 16 over 7 minus 12. And it should give us a value, what is it? Negative 75 over 7. This is just a quick way to check your answer. Negative 20x, or 20 to the x, should be 20 to the x power, plus 16 over 7 minus 12 equals y. And we're way up here from this previous one. Why does it look like that? I guess I just have a really weird zoom setting here. So let me go here. Yeah, it's got this. Okay, let's just do like negative 10, 10. That. All right, so we can see it like that. So that's more what we're expecting here. And we just wanted the y-intercept. So they read it as that. And now we just want to see if that's equivalent to negative 75 over 7. So negative 10.71428, something like that. Negative 10.71429. They just rounded it up. All right, so that does seem to work. Right. I'm assuming that this is just a rounded value of this, which is, I think, a fair assumption. All right, so those values do check out. And again, they were looking for the a value, which is what we plugged in here. It should be negative a to the x. So negative 20 to the x, a is 20. All right, so that decimal solution didn't show how to find it. It just had to verify your answer after you're done, which it was 20. The function f is defined by the given equation. So this given equation says f of x is equal to the quantity x minus 44 times the quantity x minus 46. This is a quadratic in factored form. For what value of x does f of x reach its minimum? Oh, okay, so these can help you find the zeros, right? The zeros will be when x is 44 and when x is 46. Now, to find the minimum, you would need to either use Desmos or you'd have to FOIL this out, right? So multiply x minus 44 times the quantity x minus 46, and fully distribute those. And then when it's in standard form, you could either do the calculus method I was talking about, where you find the derivative, set it equal to 0, and then you can solve for the x that way, because what value of x. Or you could complete the square, or you could do the axis of symmetry, which is when x is equal to negative b over 2a. And just you'd have to first get it into standard form to know what b and a are. So all those are options. I would use Desmos for sure on this one because it just, they're not giving you the equation already in standard form. So it's going to take more steps to do it any other way. Actually, what you could do, technically, if you know what the zeros are, right? And we know this is going to be a positive one. It being positive actually doesn't matter. But we know it's positive because if you did distribute this out, x times x is x squared, positive x squared. Right? So if you were to graph this, right, it's all the way over at 44, when x is 44, y is 0, and then when x is 46, y is 0. And quadratic functions are always going to be symmetrical. So that means that the axis of symmetry will be right between those two zeros. That's something that's always true for a quadratic. Well, that's something that you can always know will be true for the quadratics you'll see on the SAT. So if you know what the two zeros are, then if you're just trying to find the minimum value, that would be when x is halfway between those zeros. So halfway between 44 and 46 is 45. So that's really all you have to do here. I guess you don't need to do Desmos. And even if they were saying what's the minimum value of f of x, because they said for what value of x does this reach its minimum? So the x value is just how far over it is here, right? So it's the halfway point between those. But if you needed to find the output and you wanted to do it algebraically, or I guess this is not really algebraically, but this logical way, then you would know x is 45. So if x equals 45, your output will be when you plug 45 into this. So in this case, that'd be 45 minus 44 times 45 minus 46, which gives you 45 minus 44 is 1, and 45 minus 46 is negative 1. 1 times negative 1 is negative 1. All right, so f of x would be negative 1. So your vertex is 45 comma negative 1. Right, which actually, if we put it into Desmos, you're going to see this the same thing. So this is how I'd recommend you do this, actually, now that I see it. They do give you problems that you don't need to use Desmos for. I'm trying to think if there are any problems that you absolutely need Desmos. I don't think so. Like all of them will have a solution that you could do without your graphing calculator. But just a lot of times the graphing calculator is like a little cheat code that you've got. But let's just type that into Desmos. The quantity x minus 44 times the quantity x minus 46. You can see these are your zeros. It is a positive quadratic, it's smiley face. And our axis of symmetry would be at x equals 45. So right in the halfway point between 44 and 46, the two zeros, it's 45 comma negative 1. All right, and then again, they're just asking for the x value. So you just write x equals 45, or you just circle 45 as your answer. So that's how you can do that. That is a nice trick. I actually forgot that that was even a thing you could do, but yeah, that's a nice trick. If you're very comfortable with factoring and getting it into factored form, it's another way that you can quickly find at least the x value of the vertex. Then once you have the x value of the vertex, easy to find the y value. So again, it's the halfway point between the two zeros. F of x equals the quantity x minus 1 times the quantity x plus 3 times the quantity x minus 2. So this will be a cubic function, which means it will either look like that or like that. Looks like this one will be a standard cubic function. Right, so that's the one that goes like this. It's coming up, reaches this point, and it's going up further from there. In the xy plane, when the graph of function f, where y equals f of x, so this is just describing f, is shifted up 6 units, so it's going up by 6, the resulting graph is defined by the function g. The graph of y equals g of x crosses through the point 4, comma b. This is for g, where b is a constant. What is the value of b? Okay, well, what we can do, we just know any output for f of x is shifted up by 6. So if you input 0 for x, that'd be 0 minus 1 times 0 plus 3 times 0 minus 2 gives you that output. Whatever the output is, you just add 6 to it. That's going to be output for the function g of x when x is also equal to 0. So what we need to do here is just plug in 4 for f. So f of 4, and then we're going to add 6 to it. Right? That's going to be g of 4. So g of 4 equals f of 4 plus 6. Right? To shift something up, you just add 6 at the end. It's a lot easier than shifting it to the right or left for this problem specifically. So we can write this out. We'd say, okay, f of 4 would be 4 minus 1, or the quantity 4 minus 1 times the quantity 4 plus 3 times the quantity 4 minus 2, and all of that plus 6 is going to be equal to g of 4. And that g of 4 is your output, so that's what the b value will be. All right, so 4 minus 1 will give you 3. 4 plus 3 is going to be 7. 4 minus 2 is 2. So we get 3 times 7 times 2, and then we still have this plus 6 at the end. Now 3 times 7 is 21. 21 times 2 would be 42. So we get 42 plus 6, which would be equal to 48. So g of 4 is equal to 48. So 48 is our output. Now, I guess if you want to put that in Desmos, you could just type it in. Right, you would just take f of x, type all that in, put plus 6, and then you can drag it along to when x is 4. I don't really think that saves you much time here, but I guess I can show it really quickly. So you'd say y is equal to x minus 1 times x plus 3 times x minus 2. Like that. Now we scroll over, see our function. Right, like I said, it's this. It goes up. Oh, I guess I didn't really draw it perfectly. It should be actually fully going down before it goes back up. But it does start going down and going up. If you had y equals x cubed, then it does look more like this. That's just a standard, like the parent function for a cubic. But yeah, if you have it like this, it's still a cubic function. But what were they asking for when x is 4? So you could just go over to when x is 4. That'd be here. X is 4, or you could even type it in here. You'd say like x equals 4. You can see where that crosses, 4 comma 42. So that's for the f function. If you want to do the g function, you just add 6 to that, 48. Which again, you could have just taken the g value we had, 42, add 6 to it, get 48, or just add 6 to the actual function, and you'd see where it crosses at 4 comma 48. So this is a way you could do it on Desmos. I would do this one algebraically for sure, but if you feel more comfortable using Desmos, or if you want to check with Desmos, that would be how you would do it. All right, a machine launches a softball from ground level. The softball reaches a maximum height of 51.84 meters above the ground at 1.8 seconds and hits the ground at 3.6 seconds. Which equation represents the height above the ground h in meters of the softball t seconds after it launched? Oh, they have these m-sup things. I thought they got rid of these, but I guess not. So m-sup, there's just like an error with it. It's supposed to be something else there. It probably will be one of these, actually, now that I think about it, because it's generally what it would look like in physics, except sometimes it would be negative 4.9, or I think they're doing it in feet per second. Meters? Meters per second should be negative 9.8, but let's see. Well, we'll figure it out. All right, so the maximum 51.84 at 1.8. So we want our vertex to be 1.8 comma 51.84. We want another point to be at 3.6. The height is 0. So you can actually eliminate A and B right away because they put these things in the wrong spot. right? If you wanted to put it at vertex form, it would look like something where it's going to be t minus 1.8 squared plus 51.84. So that's where those vertex values would pop in there. Or for this, it's when t is equal to 3.6, and your output is 0. So they put the 3.6 as something you're adding to the t squared, but right, that would imply that t squared equals negative 3.6, or negative t squared is negative 3.6. We want it when you input 3.6. So when you put 3.6 seconds in for the value of t, the output should be 0. And 3.6 squared is not, whatever. So it's not going to be one of those. What's annoying is that we don't have this m sub value, because I think that would make it a lot easier to do this one. Now, I didn't put the a there, so the a could be this negative 16. And potentially what this is going to be is negative 16 times t minus 1.8 squared plus the 51.84. Right, so that makes me think it's going to be d. I mean, I'm sure there's a way you could make h work where it has this negative 3.6, but that would just be purely a coincidence. The input 3.6 having an output 0 has nothing to do with subtracting 3.6 at the end of something that's either in vertex form or standard form. Right? The c value should not be the additive inverse of the x-intercept, right? The 0 for a quadratic. So c doesn't really make any sense. Again, d should look something like this, negative 16 times t minus 1.8, the quantity t minus 1.8 squared. I'm not sure where the negative 16 is coming from. I think whoever wrote this might have messed up, because a lot of times in physics, you're going to use something where it's like negative 4.9 t squared minus something t da da da. And this is coming from acceleration due to gravity, which is 9.81, and then you're just doing half of it. So half of 9.8 is 4.9. But if you're using feet per second squared, that'd be 32 feet per second squared is the acceleration due to gravity in feet. Then half of that is 16, so negative 16. So whoever wrote this, which equation represents the height of this in meters of the softball, they're wrong. This would be the height in feet, but then they have meter values here. So the negative 16 doesn't actually make sense, but it should be negative 4.9. Yeah, that's interesting that the SAT made a mistake on this. Hopefully they corrected that by the time of the test that you take. I think someone hopefully pointed this out to them. Maybe it's worth bringing it up to them that this should be... Obviously, the more important thing is they should fix these m sub things, because without the actual values there, you can't determine it 100%. But this is meant to be d. Looking for that. Again, you put it in vertex form. Now, that doesn't mean that this is the y-intercept, because when t is 0, right, it's actually going to be less than this. Even though this is 0, this whole thing is not 0. You're going to be subtracting something from the 51.84 unless t happens to be 1.8. So at the time t equals 1.8, then this whole part becomes 0, and it's 0 plus 51.84. But again, that's the vertex. It's not your y-intercept in this case, right, because this is not written in standard form. All right, so it should be d. It should look something like this. Technically, should look like this, negative 4.905 times t minus 1.8 squared plus 51.84. But they have no option with that. 16, they're just doing it. They mixed up acceleration due to gravity in feet per second squared and meters per second squared. That doesn't really matter, though. You don't need to know that for the SAT. Here we have the function f is defined by f of x equals a to the x power plus b. So we have an exponential function where a and b are constants. In the xy plane, the graph of y equals f of x has an x-intercept at 2, 0. So x-intercept means y is 0, and a y-intercept, so that's when x is 0, of 0, negative 323. What is the value of b? We plug these in, I guess. We could say when x is 2, your output is 0. So f of 2 is equal to a to the 2 plus b, and f of 2 should be 0. That's your output is 0. That's the first part. And then for the y-intercept part, that's when your x value is 0. You get an output of negative 323. So a to the 0 plus b, which a to 0 is 1. So you get negative 323 equals 1 plus b. So that's the only thing you need to find b. I guess this is just kind of a red herring that they gave you the x-intercept. Or, there's probably a way that you could use it as well. But we just subtract 1 from both sides. Get that b is equal to negative 324. So, yeah, I think this is just a red herring. So ignore the the x-intercept part. The other thing they're trying to trick you on is they're hoping that people will think a to the 0 is 0. So 0 plus b equals negative 323. Just again, remember, anything to the 0 power is going to be 1. But so in this case, b, your value of b is negative 324. Now, if you wanted to find what a is, you could plug that in here. You'd be like, all right, well, a squared is equal to positive 324. So that means a is the square root of 324, which is 18. So you wrote this whole thing, it'd be f of x equals 18 to the x minus 324. And then you could check that, right? When x is 2, that's 18 squared is 324. 324 minus 324 is 0. Or when x is 0, 18 to the 0 is 1. 1 minus 324 is negative 323. You don't need to figure out that this is 18. Like, that part doesn't matter because they didn't ask for a. They could ask, like, what's a plus b or something like that, and you need to know both. But in this case, you're just finding b. You just use this part, the y-intercept. All right, we have this function, f of x equals negative 500 times x squared plus 25,000 times x. The revenue f of x in dollars that a company receives from sales of a product is given by the function f above, where f is the unit price in dollars of the product. The graph of y equals f of x in the xy plane intersects the x-axis at 0, a. Oh, I'm so stupid. It doesn't say 0, a. It says in the xy plane, y equals f of x in the xy plane intersects the x-axis at 0 and a. Gotcha. So those are the zeros of this function. It's a quadratic, so it passes at 0 and at a. And so x equals 0, x equals a. I mean, a could also be negative. We don't know. We don't know what it is. What does a represent? So a is the other 0. It's the other value of x where your output will be 0, right? Where the y value is 0. So f of x is the revenue. So it's when is the revenue equal to 0? At time 0, the revenue is 0, or input 0. What is it? X is the unit price. So if the unit price is 0, then you make 0 revenue. And if you charge enough, like if you charge $, then no one will buy it and your revenue is still 0. So the revenue in dollars when the unit price of the product is 0. No, that the revenue is 0, but that's not A. Right? A is the other input that you're doing that gives you an output of 0. The unit price in dollars of the product that will result in maximum revenue, no, it will result in 0 revenue. So not maximum. This literally would mean no one's buying it. So what's the price where when you charge that much, then the sales hit 0 again? So unit price in dollars of the product that will result in revenue of 0. Yeah, that's true. I mean, so will a unit price of 0, but they mean like an actual price. And the maximum revenue in dollars that the company can make, no. Revenue is, again, the f of x, the output. This is just looking for c. Right? So it's what price will give you that output of 0. All right, so this one, again, it's just more understanding the thing. I know I got confused here just because I misread it. I think I was trying to read it in like an announcer voice, and I misread it. I wrote 0, a, and then I confused myself. But these are just the two zeros of the function. If you have to draw a little graph like I did, that might help you. Growth of a culture of bacteria. So I'm assuming this is going to be an exponential functions one with growth factor. We have 3 days and then the number of bacteria per milliliter at the end of each day. So a culture of bacteria is growing at an exponential rate, as shown in the table above. At this rate, on which day would the number of bacteria per milliliter reach 5.12 times 10 to the 8th? Okay, well, first let's figure out how much it's growing. It looks like we're doubling. Right? We go from 2.5 to 5. They're both 10 to the 5th power. And then 5 times 10 to the 5th times 2 would give you, you could think 10 times 10 to the 5th, or if you write in scientific notation, 1.0 times 10 to the 6th. All right, so this is times 2, and then this is again times 2. So it's doubling each time. So if we wrote this out as an exponential function, you could do 2 to the x times your principal amount. So starting amount, when x is 0, it would be 2.5 times 10 to the 5th. Although this is day 1, right, not day 0. So you could write it like this, x minus 1. Or you could just divide this by 2 to start, right? Half of 2.5 would be 1.25 times 10 to the 5th times 2 to the x. Either of these are the same thing, right? Just one of them, you're subtracting 1 from when you're doubling it. So you do it like that. Or if you want, you could even just go, all right, how many times do I have to double this to go up? So you'd go, okay, at 4 it'd be 2.0 times 10 to the 6th. Then day 5, you double that, it'd be 4.0 times 10 to the 6th. Then you double that, it becomes 8.0 times 10 to the 6th. We want to get up to 512, which you notice these are powers of 2. 5.12, it's 512 is well, it's 8 cubed. So what would that be? 2 to the 9th power, right? 2 cubed. But yeah, we keep going. It'd be 7, because that would be, basically that means you're multiplying. So you'd start from 1, and then you'd have to multiply it by 2 to the 9th. So it'd be 9 days after day 3. It should be day 12, but just to check it, you go like this. 16 times 10 to the 6th is 1.6 times 10 to the 7th. And that'd be 3.2 times 10 to the 7th. 6.4 times 10 to the 7th. And then that would become 128, 1.28 times 10 to the 8th. And then you double that. Day 11 will become 2.56 times 10 to the 8th. And then double that. Day 12 it would be 5.12 times 10 to the 8th. Right, which is what we're looking for. So what do they say? On which day would the number of bacteria per milliliter reach that? That'd be on day 12. Okay, so you could write it out like that. Or again, if we wrote our function here, I guess, if you want to do it on Desmos, that might be the smarter way to do it. So we could say 2.5 times 10 to the 5th times 2 to the x minus 1. And then you just plug, that would be like y equals that. And then you also write y equals 5.12 times 10 to the 8th, and then you'd see when those two cross, which should be when x equals 12. Okay, so that would be how you would do that one. Again, or if you're good with your powers, you could skip to that. Just make sure you wouldn't go, oh, that's day 9, because 2 to the 9th is 512. Well, it's not at 1 on day 0, right? It's at 1 on day 3, so you have to go 9 further than that. Right? You're multiplying by 2 9 times after day 3, which is going to be 9 more days. 3 plus 9 is 12. So that's the other way you do it. In the given quadratic function, a and c are constants. The given quadratic function is here. It's f of x equals a times x squared. So it's a constant times x squared plus 4 times x plus c, the other constant. Right, so a and c are both constants. The graph of y equals f of x in the xy plane is a parabola that opens upward and has a vertex at the point h comma k, where h and k are constants. If k is less than 0, so k is negative, and f of negative 9 equals f of 3, which of the following must be true? So what's interesting here, they gave us f of negative 9 is equal to f of 3. So even though those aren't necessarily zeros of the function, like likely they're not zeros, a quadratic function, a parabola, at least in this normal like standard form that you'd get on the SAT, is going to be always symmetrical with respect to like that axis of symmetry, which is it would be a vertical line. So wherever that is, we know that if f of negative 9 is equal to f of 3, those are 2 points on opposite sides of that axis of symmetry. So I guess one of them is over f of 3, one's f of negative 9. So negative 9, 3. Now I'm assuming that they're down here. Oh, I guess, I don't know. That would only be if a is positive. It doesn't really matter where they are, okay? But the main thing is that means the axis of symmetry is halfway between negative 9 and 3, which you could think, what do I have to add to negative 9 to get to 3? That'd be 12. So half of that is 6. So add 6 to negative 9 or subtract 6 from 3 would give you negative 3. Or you could do like the average of those two. Just the one thing I'd be worried with, a lot of students, when they're trying to find the midpoint of a negative and a positive, they'll just add them. They forget to divide by 2. Because negative 9 plus 3, that would give you negative 6. They have to do half of negative 6 is negative 3. All right, but either way, that means our axis of symmetry is when x is equal to negative 3. Now, if you had to find what a was, be like, all right, well, we know our axis of symmetry is negative b over 2a. So that means that negative 3 is equal to negative 4 over 2a. You can figure out a is from there. Right? You just multiply both sides by 2a, divide both sides by negative 3. Get 2a equals 4/3, which would then mean that a is equal to 2/3. Okay, so you could figure that out. They don't actually care what a is, right? Oh, which of the following must be true? Actually, that does matter. Okay, so I was just trying to do that as a side thing. Let me explain that a little bit better then. So our axis of symmetry is always going to be equal to negative b over 2a. This is something that's worth remembering, right? Because it could help you find the vertex in other cases. This would be the x-coordinate of the vertex, or once you have the x-coordinate, you plug that in to find the y. assuming that you are given actual values and not just constants like this. All right, so that is the case there. So we have negative b over 2a, and then you would just set negative b over 2a equal to the axis of symmetry we just found, which is x equals negative 3, so negative 3. And now our value of b is just this coefficient in front of the x term, right? It's ax squared plus bx plus c. That's what they're talking about with the a, the b, the c, and quadratic and standard form. So b equals 4. So you just say negative 4 over, and we don't know what a is yet, so over 2a is equal to negative 3. Now we can just multiply both sides by 2a, which gives us, right, these 2a's cancel. You get negative 4 equals negative 6a. And then to get a alone, you just divide both sides by negative 6. So you get that a is equal to the negatives cancel here. The negative 6's cancel. 4 divided by 6 is 2/3. So a equals 2/3. They say a is greater than or equal to 1. That's not true. So we know it's not 2, it's not 1 and 2. And now we should figure out, is c less than 0? All right, well, we know that our a value is 2/3. Right? So if we rewrote it, it's f of x equals 2/3 x plus 4x plus c. I think the other important thing will be this k value being less than 0. So we know it's a positive parabola. We know that the axis of symmetry is at negative 3. And we know the vertex has a negative value. So this is down here, right? It has to be somewhere down here. It doesn't say how negative it is. It could be negative 0.1, something like that. We don't know. And negative 9 and 3 don't have to be the zeros, right? It's not necessarily the zeros. You could have symmetry at points that are not zeros as long as they're equidistant from that axis of symmetry. So, right, it's somewhere negative because, again, they gave us that. The k value is negative. And they're asking about when x is 0, right? Because the c value would mean when x is 0, that's your y value, right? This is going to be just your y-intercept. This is, which of the following must be true? Must? I don't know that this has to be 0 because it could be like that, and then the k value is still 0. You're going up 2 over 3, up 2 over 3, like that. So the c value being less than 0, not necessarily true. So the c value does not have to be less than 0. C value could be positive. Now, that would mean that it's neither 1 nor 2. Now, for me, that would be enough, right? For me, that would be enough of an explanation that I would feel confident in it because, I've showed that how this could be true. And again, just make sure, noting that just because the outputs of these two inputs are the same does not mean those are the zeros. I think that would be what they're trying to trick you on. But these could be way up, right? They could be when the outputs for these could be 100, right? It doesn't say anything about that. They're not in this case because the k value is less than 0 and, right, it's not a super steep y value there. Right? It's 2/3. It's less steep than normal quadratic. But they still are going to be potentially quite up there. They could be negative, right? It could be way down here like this, right? Any of those is possible. They could also be the zeros. But they don't give you that information. And if you look at all the other stuff they give you, there's nothing that proves that. So I would feel confident enough to go, well, this one does not have to be true, right? Now, it could be true, right? One can be true, but it doesn't have to be. It says this one must be true. One must not be true, or must not sounds like it's definitely not true. One does not need to be true, right? So saying that one must be true is not a correct statement. Now, one way you could do this, if you want to feel 100% confident, I would just circle D on this, but say you're like, okay, I might want to check this one, I didn't feel great about it. What you can always do is find a counterexample. So find something that meets all of these other criteria, that has this a value we solved for, so 2/3, that has, right, the rest of the equation true like that will have a k value that's less than 0, and find one that will have a c value that's not less than 0. So either c equals 0 or c is a positive value, which, we just plug it in. Right? The c value doesn't actually really matter because we already, this is going to be true with the f of negative 9 and f of 3 being equal for any value of c, right? Because we already proved that. So the main thing you have to prove is there's one that will have a k value that's down here. Let's try it. So let's say y equals, and it's supposed to be 2/3, right? 2/3 is our value of a that we solved for, times x squared plus 4x, like that. And again, what did it have to be when x is 3? So we could just do this like this. X equals 3 and x equals -9. Like that, we can find that these values are the same. The vertex is at -3, right, for the x value. That's the axis of symmetry we found. And it has a k value that's negative, right? The k is -6. So this is true, but in this case, right, our c value is 0. That's not less than 0. It met all of the other criteria, but it's 0. And, we can even move it up a little bit. We could go up to 5. Still our k value is 0. Still our outputs when x is -9, when x is 3 are the same. In this case, they're both 23. It doesn't matter what they are. This is 0, but yeah, our c value is 5 now. Okay, so it could be anything like that. It just, at a certain point it won't be true. So if you get up to 7, that doesn't work, right? Because now the k value is not negative. And there are ways that it would work, right? You could have a negative c value. You could have one that's very negative like that. You have 20, and it still meet these criteria. Right? These two are the same. K value is negative, and it has this equation. So all that's possible. But again, it said this must be true. It doesn't have to be less than 0. We could say it goes all the way up to, I think, would 6 even work? Plus 6. Or 6 is when it's, right, so k is not negative there. So it has to be less than 6. If they said c is less than 6, that would have to be true in this case. And that would be a little bit more annoying to find if you didn't have the calculator. But yeah, so that's why that wouldn't be D. I think that's just tricky because it is something you kind of have to conceptualize and you can guess and check. Like, there's not an actual value of c you can solve for that has to be true. There are a lot of different values. You should figure out, are any of the values it can be going to be greater than 0 or equal to 0? In this case, they can be. Yep. All right, we have 4 to go here. So the function p models the population in thousands of a certain city t years after 2003. So when t is 0, it's 2003. According to the model, the population is predicted to increase by 4% every n months. What is the value of n? Well, we're multiplying it by 1.04 every time the exponent goes up by 1. Now, t is the number of years, right? So t is the number of years. So for this whole exponent, the 6/4 t, to go up by 1, which is when it's going to be growing by 4%, t would have to be 4/6, right? 4/6 of a year. And I'm just doing that. I'm doing, right, the reciprocal of 6/4, multiplying by that on both sides. So 6 divided by 6 is 1, 4 divided by 4 is 1. We get t is equal to 4/6 of a year. Now, if they want to figure out how many months, n months, well, a year is 12 months, so 4/6 times 12 months, just do 12 divided by 6 is going to be 2. 2 times 4 is 8, so that's 8 months. Okay, that's all we're doing here. I don't know why this one's in the heart. I guess because you have to kind of conceptually understand what's going on with this wonky exponent here. But yeah, this is not one that will take long. It's not time consuming. It's more, I guess, just conceptually difficult for some people. Make sure you're comfortable with exponential functions. Growing by 4%, that's the growth factor. And then, yeah, if you have like a fractional exponent here, like that, just make sure you keep track of t is in years. When would this go up by 1? When t goes up by 4/6, which is 4/6 of a year, again, 8 months. I mean, you can also plug in some values, or you could do, if you want to convert it into months, you could rewrite it as 12m. So 6/4 times 12m, and figure out when does it go up by that 4%. But I think this is the easiest way to do it. The function g is defined by g of x equals f of x plus 5. And I guess the important thing we need to know, f of x equals 4x squared plus 64x plus 262. For what value of x does g of x reach its minimum? So first, let's write what g of x is. So g of x is equal to f of x plus 5. So equals f of x plus 5. I mean, you're plugging in x plus 5 for this x, like that. So that'd be 4 times x plus 5 squared, right, the quantity x plus 5 squared, plus 64 times the quantity x plus 5, plus 262. Now, if you didn't have a calculator, then you would have to multiply this all out and then find the minimum that way, which you could do, I guess you could either factor it, find the middle of the two zeros. You could do the calculus method I talked about, where you set the derivative of this whole thing equal to 0. You could use the axis of symmetry. So set x equal to -b over 2a once it's in standard form. and that would be your x value. For what value of x does it reach that minimum? And you could also complete the square, which I would say complete the square is probably the most tedious of those methods. I like completing the square, but it is more time consuming than any of those other things I said. But really what you probably do in this case is just type this whole thing into Desmos. So type it as I wrote it right there. So I'm going to write it down on my paper. 4 times the quantity x plus 5 squared plus 64 times x plus 5, or the quantity x plus 5, plus 262. And now, as an algebra teacher, I would not have been super happy with the student not, even attempting to do any of the distribution here. I probably wouldn't give a problem like this on a calculator active section. But, if you try to distribute it, there's a possibility you'll mess it up. So if you're taking this on the SAT, just make sure that you get it exactly as you're supposed to, that you plugged in x plus 5 for this f function as your input. That's your g of x. And then you're just figuring out when does it reach its minimum. So we'll go to Desmos. And I'm just going to write that. Y equals, and then the g of x function, which is 4 times the quantity x plus 5, and quantity, squared, don't forget your squareds, plus 64 times the quantity x plus 5. And I didn't even distribute that 64 to the x and the plus 5 because that's something that you could mess up potentially. So why risk it? I guess you could risk typing it in. So if you're less confident in your typing skills, then maybe that's when you do it. And then you just say the minimum value, negative 13, comma 6. Now we go back to our test. Min is negative 13, comma 6. And what value of x does it reach that when x is negative 13? So this is really the easiest way to do this one. I would strongly recommend on this problem that you just do that, especially, just if you're pressed for time, multiplying this whole thing out could be an issue. But I guess I will show how to do it, at least one of the algebraic methods. I'll decide if I want to do another one, or potentially the calculus method, but let's see. So we get x plus 5 squared. You'd have to do x times x times 5 times x. Let's give you 10x plus 5 times 5. So you have to FOIL that. Make sure you're comfortable with foiling. I have some short videos going over that. You can find 100 videos of that on YouTube. But it'd be 4 times the quantity x squared plus 10x plus 25 plus, and then distribute the 64 to both of these. That gives you 64x, and then 64 times 5 would be, let's see, 60 times 5 is 300, 4 times 5 is 20, so 320 plus 262. And now I have to distribute the 4 to all of these. Gives me 4x squared plus 40x plus 100 plus 64x plus 320 plus 262. I can just combine those right now is 582. Okay, now we still have some stuff to combine. So 40x plus 64x is 104x. So you have 4x squared plus 104x, and then 100 plus 582 is 682. Okay, so that's what g of x is equal to. G of x is equal to 4x squared plus 104x plus 282. And I think these are all multiples of 4. No, 282 is not. Or 682 is not. They're all multiples of 2. You can take that out. It'd be 2 times 2x squared plus 52x plus 341. This one's kind of annoying. I gotta say it's kind of annoying. I'm gonna do the calculus method. So I'll just do that one. I guess if you've taken calc, then maybe do this. Otherwise, definitely do Desmos. You could complete the square. You could do axis of symmetry is not too bad. Let's show that way. So x equals negative b over 2a. Just make sure you remember this. Be confident about it. Like look it up maybe right before you go on the test if you're not 100% sure. But that would be negative, our b value is 104. So negative 104 over our a value is 4. So that'd be 2 times 4. It gives us negative 104 over 8. And what will that be? I don't know off the top of my head. I guess 8 times 12 is 96. So this is 8 more than that. So 8 times 13, I guess. And we can just verify that. 104 divided by 8, that goes in like that. And yeah, that's 13. All right, so this would be negative 13, which is what we had. Okay, so negative b over 2a was definitely the best method there. I guess if you want to do the calculus way, you do, 2 times 4 gives us 8x, and then 1 times 104 plus 104 derivative of constant is 0. So we're setting the derivative of this whole thing, the g of x. So you could write it like that. G prime of x is sometimes how they'll write the derivative of it. And we set that equal to 0. So 0 equals 8x plus 104. Subtract 104 from both sides. We get negative 104 equals 8x. So the same thing we had here, negative b over 2a, because we're dividing both sides by 8. And that means that x is equal to negative 13. Okay, so either way you'll get negative 13. I would just do it the Desmos way, but I guess actually if you do it this axis of symmetry way, that's pretty quick. I used to always make my students do complete the square, and then another teacher said, oh, we usually use axis of symmetry. It's a lot faster, and the students tended to always prefer that. But completing the square is a good skill, and it's important for circles. Like if you watch my geometry videos, you'll see those. All right, this is number 21. So we got 2 to go. This one has a graph. So we've got a parabola here. It looks like a positive quadratic. And our vertex is here at, what is that, -1, -8. So just off the bat, this might not be what they're asking, but I would write it in vertex form. So it's a y equals, well, let's see, it's 1 over 2 up. So that means that our a value is 2, because usually it's 1 over 1 up, 1 over 1 up, 2 over 4 up, but it's going up twice as fast. So that would be 2 times, and then x minus h, so x minus -1. Minus a negative is plus a positive, so x plus 1. You could also think of it as when would x, you have to write something that would give you when x is -1, this thing will be equal to 0. So -1 plus 1 is 0. I don't know if I explained that well, but it's similar to, if you watch my the circles videos, I explain it pretty well with like that trick for remembering the equation of circle. And then we have minus k, right? Just too quick, it was y equals a times x minus h squared plus k. And that's why it's -8, right? The k value is -8. You're adding -8. All right, so we've got this function here. The graph of y equals 2x squared plus bx plus c is shown where b and c are constants. What is the value of b times c? Okay, well, the other thing you could do is you could use the zeros, because we know this is going to be, let's see, when x is -3, it's 0, which means x plus 3, right? Because -3 plus 3 is 0. Or when x is equal to 1, so that would be x minus 1. Right? So when you multiply these two things, this is factored form. One of them has to be 0 if you're getting an output of 0. So these are the two possible zeros. And still we have the a value being 2, which they actually give you here. Right? So put the 2 out front, and then we get 2. Now if you want, you could write 2x plus 6 and then multiply that by x minus 1. Or, but I usually do, it doesn't really matter, is I would multiply the x plus 3 times x minus 1, leave the 2 out front, and then distribute it. So it gives me x squared, what is it, plus 3x minus 1x, that's plus 2x, and then plus 3 times -1 is minus 3. And then distribute the 2 to that. That gives you that, let me shrink myself here. That gives you that y is equal to 2x squared plus 4x minus 6. So that means our b value should be 4, and our c value should be -6. All right, so if you do it this way, then what are they asking for? B times c, 4 times -6. It's 4 times -6. There we go. Which is equal to -24. Okay, so BC equals -24. You can do it like that. Or again, if we use this vertex form that we already had, you would just distribute you would just first square the x plus 1. So that's 2 times x squared plus 1x plus 1x is 2x plus 1 minus 8. And then distribute the 2 into this parentheses. Right, the minus 8 as it was. That gives you 2x squared plus 4x plus 2 minus 8. And that will still give us 2x squared plus 4x minus 6. So y equals all of that, which again, the b value is going to be 4. The c value is going to be -6. So still bc will be 4 times -6, which will still be -24. All right, so either way you do that, gives you -24. So vertex form, factored form. I think it's another method to do it. I mean, you could try to get to standard form, I guess, or I guess standard form is what we're trying to find. So from the graph, I think those are the two easy ways to do it. I would say this is something that a lot of my students would probably struggle with. I think a lot of them are not super a lot of them would not be super comfortable, even though I always tried to show them how to recognize what the equation for a quadratic would be from the graph, or to draw the graph from the quadratic. I think a lot of students start to just overuse their tricks and stuff. So this is the first of these that I'm seeing. They'll probably have more as we go into it, especially if you watch the future parts of these 88 advanced math questions that are the nonlinear functions. But just make sure that you are comfortable with going from a graph to an equation, either in factored form or in vertex form, knowing what those vertexes are. I think the thing that a lot of kids might get tripped up with is finding this a value, but they actually gave you the a value. So I don't even know that they'll want you to know how to find that. But I usually just do it as, right, it's a quadratic. Usually you go over 1, up 1, over 2, up 4. Over 1, up 1, over 2, up 4. If you just focus on the over 1s, up 1s, just figure out, all right, well, over 1, up 1, in this case, it's bigger than 1. Sometimes it'll be over 1, up a half, and then you have to go like over 2 to go up 1. That would mean it's times 1/2, right? So if you figure it out like that, you just basically need 3 points to figure out what it is, or even technically 2 points. All right, so this is the last one I'm going to go over in this video. Again, the other 66 of these advanced math nonlinear function questions will be in future videos, which hopefully I'll get them up also very quickly, at least some of them. I know that some students are taking the SAT soon, so they want to see those. But hopefully do a good thorough explanation of this last one, and then comment below if any of the questions that I had were confusing or whatever, and I'll try to get the rest of this quickly. So this one says the function f is defined by f of x equals the quantity x minus 6 times the quantity x minus 2 times the quantity x plus 6. In the xy plane, the graph of y equals g of x is the result of translating the graph of y equals f of x up 4 units. Okay, so again, it's an up one. So all you do is just take f of x and you add 4 to it at the end. Now, if you shifted it to the left or to the right, that's still considered translating it. If you translate it to the left or right, then you'd have to either do f of x minus 4 to shift to the right, or f of x plus 4 to shift it to the left. That would be a little bit more challenging. Now, we did have one like that, where it was the f of x plus 5, I think, if you go back a couple questions. And you saw that it took a decent bit more work. This one's going to be pretty easy. So f of x plus 4 is just going to be x minus 6, the quantity x minus 6, times the quantity x minus 2, times the quantity x plus 6, plus 4. You just add that plus 4 at the end. Now you can type that into Desmos, but we just want to find when g is 0. So g of 0, g of x equals this. So g of 0 equals f of 0 plus 4. But you could just find what f of 0 is, plug it in, which would be here. So plug in 0 minus 6, 0 minus 2, 0 plus 6, like that. And then make sure you still have this plus 4 at the end. And it's shifted up 4. So 0 minus 6 is equal to negative 6. 0 minus 2 is negative 2. 0 plus 6 is 6. And then you have plus 4 at the end. So we just multiply these. PEMDAS, you have to multiply before you divide. Negative times a negative is positive, so those cancel out. 6 times 2 is 12. So we get 12 times 6 plus 4. 12 times 6 is going to be 72. So 72 plus 4 gives us 76. So 76 is the output when g is equal to 0. You could type that into Desmos. If you did the f of x function, it would give you f of 0 is 72, and then you add 4 to that. Or you could just type this function in here for Desmos, type in x equals 0, or you just see what the y-intercept is, and it would be 76. All right, so that would be that first 22 questions on this nonlinear functions of the domain advanced math. You can see there were a lot of quadratics, a lot of exponential functions. They had some a little bit out there stuff that was neither of those specifically, but just make sure that you're comfortable with them. Even though these were the hard ones, I didn't find any of these to be super, off the deep end. I think some people might struggle with the conceptual ones. Some people might struggle with ones where you have to, interpret a graph in terms of a function. Just make sure that you're comfortable with vertex form and standard form. Hopefully factored form is something that you're very comfortable with. And knowing some tricks for finding, right, the vertex, even when you're not given the equation in vertex form. So I'd assume that the easy and medium sections have more questions where they give it to you in vertex form. You have to interpret what that means. But for this, I think more often it would give it to you in standard form or give it to you in factored form. And then you have to be able to determine from that what's the vertex. And the tricks you have Desmos. So you could use Desmos, figure out the vertex that way. A lot of times that's the easiest way, or one of the easiest ways. You could use the axis of symmetry, which we know the axis of symmetry for quadratic will always be x equals negative b over 2a, assuming it's in standard form. That's ax squared plus bx plus c. Right, so we're using this for that numerator. or negative that for the numerator, and this for half of the denominator, so 2 times that. All right, so that would help you to find the x value. If they want to find the actual output of it, that's different. You have to then plug it back in. And I mean, you could use for factored form. If you have it in factored form, it's just going to be the middle of those 2 points, right? So just, no, it's the axis of symmetry. So if you've got 2 points that are, right, they have the same output value, the same y value, then the axis of symmetry will weigh halfway between them. It's the axis that cuts them in half, that, you know, that they're equal on either side of it, whether it's frowning or smiling, right? So that's another trick you can use. And, you know, just make sure that you're comfortable interpreting these in context. You don't always need to fully understand like what each element in it is talking about. Just if they're asking about the y-axis, if they're asking about the x-axis, they're asking about the zeros, just know what that thing they're asking for would mean in this context. And besides that, I mean, this one was interesting just because they made an error. A lot of times I'll think they'll make an error, or, you know, maybe they have the msup, which means that it's like a formatting error on this. But the fact that they actually used the feet per second squared instead of meters per second squared, even though it specifically says meters, I thought that was interesting. It doesn't really matter though for this problem, as long as you can interpret what the vertex form would be for that to make that true, given the information they gave you. Okay, this one, yeah, this is similar to the one we just did actually. And another one with the axis of symmetry, or I guess that was more the zeros. Exponential functions. Yeah, make sure you're really comfortable with exponential functions. It's usually a very short unit in your algebra class. It's just if you review those notes. If you have questions, you can comment those below and I can try to answer them, or maybe even make another video quickly going over some exponential stuff. There's a lot of good videos about exponential functions though online. Well, I don't know if that's actually true, but there are at least some good videos. Maybe I could add to them if there's a severe dearth of them. And yeah, this was the only one. When I saw this one, I was thinking, oh, there will probably be a lot of absolute values in this, but there were really not that many absolute value questions. They just happen to have that one there. This one was interesting too. A lot of times I find that the sets, I mean, I just do them in the order that they generate when you populate all of them on the College Board website, like the question bank website, and then, you know, export it as a file. But it seems like a lot of times they'll put a weird one in the first couple questions, so then I assume that's what a lot of them will look like, and then it's not the case. But yeah, this one, I mean, you have to kind of conceptualize why they're giving you the a is less than 0. It didn't really affect it so much in this case, but it would just be something that would psych people out. Oh, and even this first one was a little bit weird. But again, you know, if you're using Decimal, it's not too hard. Or you could use the quadratic formula, the same thing. All right, so that is the first part. I'm going to have ultimately 4 of these, so 3 more specifically for the nonlinear functions. They have other things. I think it's nonlinear equations and then something else that's also considered advanced math. So I'll get the hard videos of all of those. Hopefully I'll get them somewhat soon. I think I'm going to prioritize the nonlinear functions for now because someone commented that they really need those for this upcoming October SAT, which I believe is this weekend. So I'll try to get those up quickly. And yeah, if there's anything that you absolutely need, even if it's just like one specific concept, I could try to get that up, or, you know, even for a future SAT date. As long as I see the comment in time, I can do my best to help out. But yeah, appreciate the feedback. If you have any other comments, if you found an error in one of these, if you had a different way of doing it, or you have a question about a different way that you did do it, see if it's actually another optimal solution, make sure to put that below in the comments. If you found this video helpful, make sure to like and subscribe. That will promote more videos like this in your feed, and we'll promote it out to more students. So, you know, hopefully if these are useful, it could be something that could benefit more people who are preparing. And besides that, yeah, thank you for watching. Good luck if you are about to take the exam, and good luck with the rest of your preparation. And yeah, hope to see you in the next one. Thanks.